mathematicians. In this video, we're going to dig deeper into the standard form of a linear function and discuss the restrictions on A, B, and C. Some mathematicians don't worry about these restrictions, while others are strict about them. So I think the best thing is for you to know what they are, and then you can make some decisions for yourself. So let's discuss the restrictions. The first restriction, and we'll go through these and then look at an example. The first restriction is that A, B, and C must be integers. Make sure you remember what an integer is. Integers can be positive, negative, zero. They just have to be whole numbers. Well, whole positive, negative numbers. Can't be a fraction, can't be a decimal. Second restriction is that A must be greater than 0. So this means that A cannot be a negative number. The third restriction is that the GCF, the greatest common factor of A, B, and C, must be 1. This means that A, B, and C have no factors in common, that they are relatively prime. Let's look at an example and see how we can deal with each of these restrictions. So my example is y minus 1/3 x is equal to negative 2/5. First off, I see that this is not in the form because my x term is not first. So I'm going to rewrite this to be negative 1/3 x plus y is equal to negative 2/5. Okay, my restriction, A, B, C must be integers. They are not all integers. I have fractions for these two, for A and C. I know that their lowest common multiple is 15. So I'm going to multiply both sides of this equation by 15, and that's going to clear those denominators, and I'll be left with integers. We've used this technique before when solving equations. 15 times negative 1/3 is going to be negative 5x. 15 times y is 15y. These divide out, 1, 3, and we're left with negative 6. Okay, next, is A greater than 0? No, negative 5 is not greater than 0. So I want to change the sign of negative 5 to positive 5, which means I'll multiply both sides of the equation by negative 1. Some mathematicians look ahead, and in this step, they would have multiplied both sides by negative 15 instead to also change that sign to positive. So something that you might want to do as well. I'm distributing that negative will give me a positive 5x minus 15y is equal to a positive 6. And lastly, I'm going to look at the greatest common factor of negative 15, excuse me, and 6, and it is indeed 1. So this is an equivalent equation to this, but written in standard form with the restrictions. Let's end with, I want you to try one here. I'm going to use the equation 3/2 y minus 6x is equal to 9/5. Please pause me and go ahead and put this in standard form following all the restrictions, and then come back to check. Did you get 20x minus 5y is equal to negative 6? If so, you're good to go. If not, hold on for a second and we'll just walk through it together. For those before you go, now that you know the restrictions for A, B, and C, you as a mathematician should now consider how strict do you want to be with yourself? Do you want to always follow these instructions? Do you want to never follow these restrictions? Or do you want to find there's some cases when you do and some cases when you don't? I know I'm actually stricter on these restrictions when I'm looking at just a general equation that doesn't really have any meaning or context in the real world. While other times when I have the equation for real world situations, I'll often keep the fractions or decimals in particular because they often have a meaning for that problem. So you'll get to decide for yourself. All right, if you're good to go, see you later, mathematicians. If not, pause and let's stick around and let's go through this example together. All right, to handle all these restrictions, first I want to get the terms in the right order. So I'm going to have negative 6x. I want the x term first, plus 3/2 y is equal to 9/5. My a, b, and c are not integers. My least common multiple of 2 and 5 is 10. So I'm going to multiply both sides of the equation by 10. distribute that 10, I'll get negative 60x. 10 times 3 halves will be 15y. And then that divides out to, and that's equal to 18. My next restriction is a greater than 0. Absolutely not. It's negative. I'm going to multiply both sides by -1. Again, you could have looked ahead and multiplied both sides by -10 in the previous step. It's going to change all my signs. I have 6x minus 15y is equal to -18. Next, I'm looking at the GCF of 6, -15, and -18, and I see there is a greatest common factor, and that greatest common factor is 3. So I'm going to divide both sides of this equation by 3, and that will divide out that common factor. 6x divided by 3 is, you know what? I needed a 60, 60, 60. I hope you found that along the way. So 60x divided by 3 will be 20x minus 5y is equal to -6. And I'm done here. It follows all of the restrictions. All right, I hope that helped. Can you find and fix your error? If not, let's talk about it. You can send me a chat or an email or ask me in class. All right, see you soon, mathematicians.